This video will cover some example problems from section 5.5 of Precalculus. Mainly this chapter just deals with the law of sines, so we'll get right into that right away. The law of sines states that if you have a triangle ABC with angles capital A, capital B, capital C on opposite the side lengths lowercase a, b, and c respectively, the following equation is true. Sine of angle A divided by side length A is going to equal sine of angle B over side length B, which is going to be equal to sine of angle C over C. When I say over C, don't think like Afghanistan or Europe or something like that. I'm just talking about the side length C, so not to be confused with that. So first hour, there's your joke for the day. Now, the important thing to remember here is that this law can be used with any triangles. We're not talking right triangles anymore for this law of sines. You can use it for any triangles. So what you're going to do is you're going to set up a proportion to solve for a missing angle or side length. If you're looking for an angle, obviously you're going to use an inverse trig function. If you're using a side length, you're going to generally use your calculator to help you figure out what the sine of one of the angles is, or two of the angles is, and then get the missing side length from that. So you could be matching up, you could be given angles A, B, and side length A, and you'd be solving for side length B. You could be given angles B and C and side length C and solving for B. You could be given side length A, side length C, and angle C and solving for angle A. There's a lot of different options you could have there, but you need 3 out of the 4 positions in the proportion. So let's just jump right into it and work through an example problem. So if you're given angle A is 38 degrees, angle B is 46 degrees, and side length A is 9, I would expect you to set a proportion from that. Remember that if I'm asking you to solve a triangle, I'm asking you to find all the missing side lengths and all the missing angle measures. So in solving this triangle, maybe you would first find the third angle, since all the angles in a triangle have to add up to 180 every time. You would simply subtract the 2 given from 180 to get the missing angle measure C. You can then set up your proportion. Sine of angle A, which would be sine of 38 degrees over side length A, which is 9, is going to equal the sine of 46 degrees over side length B. So as you can see, I've simply replaced A with 38 degrees, angle A with 38, side A with 9, angle B with 46 degrees, and I'm solving for side length B. From there, you just solve for B. At this point in your math careers, you should know you can cross multiply. You'd get B on top over here. You'd get B times sine 38 degrees equals 9 times sine 46. Divide by 38 degrees and end up with your answer. B equals 10.516. You can work very similarly to find the last side length that you need, using that 96 degrees instead of the 46 degrees that angle B is. From there, you solve the triangle. The situation that you have to be aware of is when you are given 2 side lengths and an angle measure, it's possible for 2 triangles to actually have those side lengths and that angle measure. which means you have to check and see there might be two triangles that you have to solve for. So to do this, you do the same thing that we did before. You're going to set up and solve just like you normally would. So you would take, and you would take, since you're given angle A, sine of 30 degrees over 7 would need to be equal to the sine of angle B over 6. Cross multiply, divide, do all that good stuff, and you get sine B would need to equal 6 times sine 30 over 7, which would equal 6 times 1/2 over 7, which would be 3/7 is what we're saying sine B is. So I'd have to take the sine inverse of 3/7 to get the measure of angle B, which would be approximately 25.4 degrees. So now I've got two of the angles. I can take 180 minus 25.4 minus 30 to get the missing angle, which would be angle C. And that would be, let's see, 150, 124, oops, 124.6. And finally, I'm just missing one more side length, so I can take